Sravya Kondrakunta. She's going to talk about goal graph and goal operations in MIDCA.
Hi everyone, I'm Sravya and I'm going to discuss a few points about goal graph and goal operations in MIDCA. So let's get started. What is a goal graph? A goal graph is a data structure which organizes and manages all the goals of the agent in a hierarchical format or a tree structure. The current goal graph in the MIDCA has three classes associated with it. The first one is the goal, the second is the goal node, and the third is the goal graph. The goal contains ID and arguments, which means the ID is the predicate of the goal and the arguments are the objects related to that predicate. And then the goal node contains four objects within it. The first one is the goal, the second one is the parent set, the third one is the child set, and then the children set, and the fourth one is the plan to achieve the goal. And then the goal graph contains all the relations between the nodes. That is, it might be a single node might be a parent to some other node, or it can be a child to some other node, and all those things. So the goal graph structure helps the user and as well as the agent to prioritize all the goals which it has. So let's take a look at how the goal graph is working. So whenever the MIDCA is initialized, an empty goal graph is also initialized with MIDCA and is pasted into the memory of MIDCA. And whenever these new goals are inserted or inputted by the user or by the agent, the MIDCA performs goal validation on those goals, to check if the goal is really valid one or the correct one. And then if the goal passes the goal validation test, then those goals are inserted into the goal graph in the memory, and later on fetched from the memory, acted upon, achieved, and then removed from the goal graph. So let's take a look at this in detail with the help of the MIDCA architecture. So here the perceive phase does not have any interaction with the goal graph. It just currently observes the world and updates the states of the world into the memory. The interpret is the one which gets all the goals. Those goals might be the user provided one, or generated by the agent itself. And then the interpret only validates the goal based on by checking the ID and arguments of the goals. It initially checks if the ID belongs to the domain file defined in MIDCA, and arguments are already in the state file or not. And if these two tests are passed, then the interpret goals then the interpret phase inserts the goals into the goal graph and stores it in the memory. And then the evaluate phase checks to see if the goal is achieved or not. If the goal is achieved, then the evaluate phase removes the goal from the goal graph. And the intent phase is where the goal selection operation happens. We'll talk about the goal operations in the next few slides, but just to make sure, the intent gets all the goals from the goal graph, and then selects some goals based on some criteria, and inserts those selected goals into a stack called current goal stack. And then the plan gets that current goal stack, and then checks to see if a plan already exists for that current goal. If not, then it would generate a plan and insert it into the goal graph. If a plan already exists, then it does nothing. And then the act phase iterates through the plan and executes each action at a time. And in the meta phase, in the meta phases, the plan also interacts with the goal graph in order to perform the goal transformation operation, which we'll talk in the next slide. So if you want to better understand the goal graph working with the example, please take a look at the previous year's demo. It will be more clear than here. And So here are few goal operations which are already implemented and are yet to be implemented in MIDCA. The first one is goal formulation. The goal formulation is when the agent generates its own goals without the help of an external user. The goal selection operation happens when there are more number of goals to achieve in front of the agent, and it is not in an state to achieve all of those. And then the goal transformation operation happens for several reasons. One of the reason is the lack of availability of resources, and the other reason might be some other goal is more important to the agent than the goal it is working on. And then the goal delegation is the operation of the agent delegating its own goal to some other agent or the user himself, because it comes into its knowledge that it is no longer in a position to achieve that goal. And then goal achievement checks to see if a goal is achieved or not. And then the goal monitoring, this is the work of Zora, and she's currently working on it. It checks to see if the reasons to achieve the goal are still valid or not. So let's go into detail. Let's talk a little bit of detail about some goal operations here. So the goal selection operation, as I said earlier, this happens when the agent has a choice of multiple goals and it cannot achieve all of those. So after knowing this, we come to a question, and we come to a question on what basis do I choose. So here in MIDCA, we have used we have implemented this ratio of performance to limiting factor, where the performance and limiting factors are domain specific, but the estimates of the performance and the limiting factor are estimated by the agent. uh, uh, by the by the agent, we call this smart selection criteria. You and This idea is borrowed from Johnson. His work was very domain specific, and we tried to generalize the work to different domains. Let's take uh, look at a specific example to better understand this criteria. So here, let's take a look at the construction domain example. Here the agent has two goals, to construct the building B1 and the building B2. So for each goal it achieves, it would be given a credit, say 1, and the limiting factor here is time, and the agent should complete all of the goals within its time limit. So to be more clear, to place the block A, the score it would achieve is 1 here. And then the time taken to put the block would be 1, and for the B and also the block E, the score would be 1 and the time taken would be 1.2, and it is the same for the other one. And as the height of the tower increases, the time taken to place the block also would increase. The time and the score are currently provided by the user. So if we take a ratio, the ratio of performance over the time for building B1 would be 0.88, and for the building B2 it would be 0.9. And if the agent had all the amount of time in the world, there is no need of this goal selection operation, because the agent could do each and every could achieve all of its goals one after the other. But in the real world, this would not be the situation. So let's say if the dead if the agent is asked to perform to achieve these goals within a deadline of say 5 seconds, then then the agent is forced to perform the goal selection operation. And in our method it would select the building B2 because it has the performance over time. Earlier it was the minimum ratio, but then we changed it to the maximum ratio in order to maximize the performance rather than uh, checking it for the time being. Oh, sorry. Okay. So that was the goal selection operation. And the goal change operation, this currently is implemented in MIDCA whenever the MIDCA is out of the resources, or whenever the MIDCA encounters any emergency situations like the tower being on fire or something like that. Uh, so even this is implemented in construction domain. So we would call that a tower is stable when the tower is constructed with the help of motor, and we would say the tower is not stable or wobbly if the tower is constructed without the help of the motor. So this is implemented in the control phase, that is the meta phase of the MIDCA. So the MIDCA would be given a certain number of motors, and then it would be asked to achieve all sturdy towers. So it has to use only the stable ons, after certain time it would be out of motors, and then it has to it would be out of motor, and it would be left with any choice. So there comes the goal change operations, and then the agent would itself change the operation of stable on to on, and then complete the construction of the tower without the help of the user directing it to change its goal or anything. So we have implemented this goal change operation using predicate transforms, where the generalization means moving into more generic predicates, specialization means moving into more specific predicate, and identity means uh, stay selecting the same goal again, and abstraction is similar to generalization but for objects, and concretion is also similar to specialization but for objects as well. So this is how, with the help of predicate transform, we have implemented the goal change operation in MIDCA. And the one more important operation happening in MIDCA is the goal formulation. MIDCA is able to formulate its own goals whenever it encounters an anomaly. This happens in interpret phase of the MIDCA. Whenever a block is set on fire or something, then the MIDCA generates its own goal of putting off the fire, and then it gives it the highest priority. Uh, so that's it. So let's take a look at the future work here. We are wanting to introduce a new variable or something called goal type, which would say which would associate the type of the goal into the goal graph. We think that this with many other factors would help in integrating or making the goal operations more flexible. And we also want to make the all the goal operations work simultaneously. uh, Currently these operations are implemented, but all of those are independent of each other. And these are also domain specific, and we are trying to bring everything to every domain uh, till now. And so that's it. Thank you.